The volume of prisms and cylinders. So, volume is the amount of space inside a three-dimensional solid. So if you wanted to fill this object up with water, how much water would it take? Prisms have the same cross-section throughout their height. When you draw a prism of any sort, you see that it has two congruent bases, and they're connected. And no matter where you cut it, you're gonna see the exact same cross-section throughout. So essentially what we're going to do is we're going to take whatever that cross-section is and multiply it by the height. That cross-section is the base. So the fundamental idea is that we're taking the area of the base, area, times the height. So the volume of a prism is the volume equals the area of the base times the height that's perpendicular to the base. So for rectangular prisms, we have length times width times height. Well, the length times the width is the base. So sometimes you see this written length times width times height rather than just the base times the height. For triangular prisms, the base is now 1/2 length times width, and then times the height, which is the 12. So in this problem, it would be 1/2 times the length times the width times the height. For cylinders, the area of the base is pi r squared. So because it's pi r squared, we have pi r squared times height is the volume of a cylinder. So overall, these are the formulas that we just went through. That the prism is base times height. Rectangular prism specifically is length times width times height. Triangular prism is 1/2 length times width times height, and cylinder is pi r squared times height. So let's find the volume. This is a rectangular prism. It's actually a square prism, but rectangular prism works. 2, 2, and 4 are three perpendicular sides, or for three perpendicular lengths. It is important that they're perpendicular. 2 times 4 gives us a total of 16, and our units for volume are always going to be cubed, so cubic miles. For this, we have pi r squared h. So r is not 8. R connects the center to the side, so r will be 4, and 2 is our height. So 4 squared is 16 times 2 is 32 pi, and then cubic yards. Here, this was not one of these three. We can just use the general prism formula. So the area of the base times the height. So the area of the base is 1/2 base 1 plus base 2 times the height of the trapezoid. So the base 1 is 5, the other base is 8. The height of the trapezoid is 4.8. And now when we multiply this together, we're going to get 31.2 is the area of the base. So 31.2. And then now we want to talk about times the height. The height is what connects the front to the back, or the top to the bottom, depending on what type of prism it is. And this is 10. So our answer is 312 cubic centimeters. Please note that if you see an oblique solid, a slanted solid, it has the same volume formulas. This is based off of Cavallari's principle, which says that all that matters is the cross-section at each point. So because the cross-sections are all circles, it's still the same. So here we could still use pi r squared h because it's still a cylinder. This doesn't work the same way for surface area, but for volume it does. So the radius is 5. The height is 15, and then we do 25 times 15 gives us 375 pi cubic centimeters. That's volumes of prisms and cylinders.